The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, and welcome to this session on Geospatial Frontiers, navigating the future with generative AI and foundation models. My name is Andrea Manara from the ITU, the International Telecommunication Union. It is an honor for me to introduce a new episode in the GeoAI Discovery series. We launched this series back in 2022, and we discussed the several GeoAI applications and policies, ethics, and the future of GeoAI for Good. Thematic sessions included climate actions, spatial digital twins, energy, ecology, agriculture, water and food systems, health, and more recently, we're focusing on GeoAI and education under the leadership of Maria Brovelli. If you missed some episodes, don't worry, you can watch the recordings of those events on YouTube or in the neural network to which you are connected right now. Without further ado, let me now introduce the other moderators of today's events, Rohini and Maria Brovelli. Rohini is a geospatial expert, Rohini Sampurnam Swatinam, a geospatial expert with 12 years of experience, international experience working with humanitarian and development sectors. She currently heads the Geospatial Support Unit at the United Nations World Food Program and previously served with the UNICEF, WHO, UNDP, UNITAR, and the NASA Development Program. Maria Brovelli. Maria is the professor of GIS at the Politecnico di Milano and member of the School of Doctoral Studies in Data Science at Roma La Sapienza. Amongst her many activities and duties, Maria is Vice President of the Commission of Geospatial Information of ISPRS, Chair of the UN Global Geospatial Information Management Academic Network, and co-chair of the United Nations OpenGIS Initiative. I will now give the floor to Maria. She will introduce the speaker of this session, and she will also moderate this session. Maria, the floor is yours.
Andrea, thank you so much. And good afternoon, good morning to all our friends and followers. I will say that there are many people attending these amazing webinars. So I'm very happy to introduce to you the guest of this episode, who is Blagoy Delipetrev, who is also a friend of mine, not only a very excellent researcher. So let us say something about Blagoy before giving him the floor. Blagoy is a distinguished AI developer and academic. He has 2 doctorates in computer science. He earned his PhD in machine learning and AI optimization algorithm from the Delft University of Technology, and then the second PhD in cloud computing applications from the University of the Saints Cyril and Methodius. With over a decade of expertise in AI research and project leadership, Blagoy has become a leading figure in his field. In his role at the European Commission Joint Research Centre between 2017-2023, Blagoy was a scientific officer and task leader for the AI Watch project, contributing to the European strategy for AI and data, with a particular focus on the development of generative AI. He has promoted then to the role of full professor of computer science in 2021. But beside that, Blagoy's entrepreneurial spirit led him to found Bit Solution in 2015, where he also served as CEO, steering the company to the forefront of AI consultancy and software outsourcing. His strategic foresight has culminated in the development of transformative AI solutions across various sectors. His devotion to both theoretical advancement and practical application guarantees that his endeavors extend beyond academic contribution, fostering tangible societal progress. So congratulations, Blagoy, for this splendid bio that you have, despite the fact that you are so young. So congratulations, and then I'm looking forward to seeing your presentation. So over to you, Blagoy.
Thank you, Maria, for the great words, and I'm also very happy to have you as a friend. I think this is probably the most important. I think now you should see my screen. It would be good if somebody says that.
Yes,
that's
we saw it.
That's great. Perfect. So thanks again, Maria, for the great introduction, and I'm really happy to be here and to present to all of you. I would say the geospatial frontiers, what is the future of generative AI and foundation models. And I hope that at the end of the presentation, you will all learn something new and implement in your job. So let's start. Why don't it goes to the next slide? So let's start with what is generative AI. I think this slide should, be skipped, but it's good to maybe sometimes just repeat what it is. In the last, I would say, year and a half, generative AI has taken the world by storm. So if I think the news and the whole media and even the applications are really growing exponentially. So it's all around us, I would say, if it wasn't previous. And the first or the most known example of generative AI is definitely ChatGPT. So if you haven't used it, I strongly suggest to start using it immediately, because it will really open a lot of ideas and possibilities that you didn't know that existed before. So just to make an example, you can say, like, please write me a paragraph poem of the title of this presentation, and it's going to do just that. So it's going to write you a poem, although not, for example, me, I'm not a poet, so it would be very difficult for me to write this kind of a nice written poem and to make it in 2 paragraphs. And I forgot to add, also generate me an image. So on the right side, ChatGPT-4 and GPT-4, it's connected with DALL-E, which is the image generator. So depending on the prompt that you're giving it, is going to generate you a text and is going to generate you an image. This is ChatGPT, GPT-4. Through the presentation, I will talk about many other tools. It's not only them, but let's say this is how the generative AI started, and it's nice to say it. It's not only text and images, or it's more than text and images. Midjourney, it's another example of generating images. And for example, you can put a prompt like, give me an ultra realistic photo of Walter White, Breaking Bad, standing in the middle of the road, close up with bright realistic lighting. And what is even, I would say, more impressive is that if you had this prompt in 2022 in July, you will get the image on the left. But if you made the same prompt in December 2023, you will get this image. So this shows also the pace of development of these technologies. So it's really remarkable how fast are they moving. There is a big competition between multiple players, so they're also pushing the boundaries faster and faster, and generating more and more photorealistic images. If you think that that is still not impressive, then definitely the last presentation of OpenAI Sora, which is a model to generate videos. I think it's really something that blows a mind. So you can prompt like, give me a photorealistic close-up video of two pirate ships battling over each other as they'll sail inside a cup of coffee. So, I mean, this is really amazing. So you have two ships, you have a cup of coffee. The cup of coffee, if you watch it closely, there was a big debate on Twitter. Does it understand the physics? No, it doesn't, but it really well simulates how the fluids are moving. So you see how the coffee is moving, how the ships are moving. So this was one of the most impressive for me, possibilities of generating video based on a prompt. So you just give it a prompt and it's going to generate your video. What I didn't mention, which is really maybe more important, is that with better prompting and more focused prompting and follow-up prompting, especially in large language models, you can get even better results. So if you're not satisfied with the first image, or if you're not satisfied with the first poem, or with something that was generated, you can follow up to the AI agent, AI tool, and say, okay, this is good, I like it, but can you please make it shorter, make it longer, or can you add something which, for example, if it's a video, lightning, or it's I don't know, it's a sunset. So the let's say the beauty is that the AI understands what you want and it's improving in the next iteration. So if you're not getting what you asked for in the first iteration, then definitely after a couple of iterations, you will probably get what you like or what you asked for or close to it. Of course, I would say much lower in the presentation, I'll explain why language is more, let's say, solved, while images and video it's the last. In fact, I would say it's less possible to generate exactly what you want. But this is just because of the compute and the models. So how it all started? It all started with ChatGPT, November 2022. So I was working at the European Commission at the time, and my job was, in fact, to follow technological progress of AI and report on this in a way in many reports that I contributed in the Commission. And my really job was to track what is happening, like what is happening in the large language models, what is happening in the computer vision, etc., etc. Tracking the large language models, there was progress, definitely, but not so big, I must admit. The 3-4 months before ChatGPT, Facebook released, I think it was called Galactica. It was really like a lot of buzz around the world, but the model didn't work well. In fact, the biggest problem for large language models at that time, before ChatGPT, was to follow up a conversation. So usually the first prompt, it will get it right, but the second prompt, if it's a follow-up on the first prompt, then usually it's getting lost. On the third prompt, it's completely lost. So it was not possible or completely unusable for chat. And this was the case for everything before ChatGPT, or very few maybe examples that I have missed were doing something. But in general, there was progress, but not so big. Or when ChatGPT was first released, I was really like caught completely out of bloom in a surprise, because when I started using it, I was like, this is not possible, because it was a very big difference from anything before. I even talk with colleagues that work in AI, and we have a group chat, and I was writing to them like, oh man, this is really something, it's not like before. And they shared their opinion, and really it popped up that it is the thing that changed everything. And since then, I'm very passionate about generative AI, since November 2022. And it's obvious that I'm not the only one. And these are the stats that shows the tremendous success of ChatGPT. I think this is really amazing. So to get from 1 million users to 100 million users, the big applications that we all know, like Netflix, took like almost 10 years. Twitter took like, I cannot guess, but 5-6 years. The fastest was Instagram, that took like 1,000 days, which is around 3 years. ChatGPT got from 1 million to 100 million users in a matter of weeks. So I think in December they were hiring like crazy OpenAI to scale up. Even they had the backup of Microsoft. They needed a lot of engineers just to scale up the demand. So they really got a lot of users initially, and that's also visible on the most visited website on the internet. OpenAI became on par with Reddit or with Netflix, which are, I would say, applications that many people use on daily basis. And of course, also the demand on Google Trends with ChatGPT compared to TikTok. TikTok is the most used social network. So really, world was taken by storm. And I think since that point in November 2022, everything changed. Previously, again, we had developments. Stable Diffusion, I think, was before GPT. There were GPTs before ChatGPT. So ChatGPT is 3.5. There were GPT-2, GPT-1. But still, I think this is the iPhone moment, as I will say later in the presentation. So who is who in this landscape? Really now, currently, everybody is rushing like crazy into generative AI. The 4 front runners are the biggest, most valuable companies in the world, and that's a fact. So Microsoft has invested a lot. They are one of the first investors in OpenAI with $13 billion, I think, even before ChatGPT. So they are backing up OpenAI from the start. Google, it's my opinion, it's not performing on its capacities. So Google is definitely the company with the most data under its hood, with the most compute available also. They are producing models, but they are still, I would say, struggling, or they are trying to catch up with some other players which already set the boundaries pretty high. But they are still here. They're producing good research. I'm not saying that they're not, but maybe not in the driving seat. Meta, it's doing amazing job. Meta decided to go the road of open source and open access. So their models in large language models are the most used, and not only in large language models. I think whatever Meta publish, because they have a lot of compute and they have a good team, definitely. So they publish a lot of open source models, and they're very useful for the community. Apple is here. Just to mention, I think it was news for 1 week ago. They shut down complete division for autonomous driving or driving. They were trying to build a car. Now they're put all the money into generative AI. They are into spatial computing, but spatial computing and metaverse will use a lot of generative AI applications or tools behind it. So NVIDIA, it's on top of the news in the last month. What can I say? They are the top producer of GPUs. Everybody is using that. Demand is over the top. They're making a lot of money. They became $1 trillion company very fast. They're growing very, very fast. Amazon, with Amazon's web services, is definitely also investing a lot in this area because, you know, everybody knows that this is the future. This is what companies would like. And of course, this compute is pretty expensive. That's also important. So they're big spenders for compute, and they cannot allow, you know, the big Amazon Web Service not to have this part in this story. And just below are some of the most famous partnerships like OpenAI and Microsoft. Anthropic, it's a similar company to OpenAI, of course, maybe not that strong. They are using Amazon Web Services. They have a strong partnership. There is Inflection, Cohere, Hugging Face. It's a very, I would say, interesting company that you should definitely bookmark because they are like GitHub for code. They are having all the models are open source models are stored there. They have multiple partnerships, Runway, etc. So these are, let's say, the most famous startups on the left with already established and big companies on the right. Global Unicorn Club, as I said, this artificial intelligence part are companies which are valued over $1 billion, and this is in fact figure from last year. I haven't updated this figure, but this didn't exist 6-7 years ago. So this is a new class of $1 billion companies which exploded in the last 5-6 years in AI. So the landscape is pretty big. Of course, we have to be in mind that the big players are here, but there are also a lot of startups and a lot of developments going on. If you are the front runner, you need enormous amount of money to keep pushing the boundaries. We just, how can I say, we don't know the figures always. There are figures, but very little in the news, which pop out of some of the companies. For example, Zuckerberg was kind enough to share that he's going to buy 350,000 H100. These H100 are GPUs, NVIDIA, which are very common GPU used for this purpose. So he's going to buy 300,000 pieces of this equipment and double the computational power of Meta. And he's going to spend like $10 billion only for GPUs. So it's enormous amount of money. Plus you need infrastructure, people, so you need really a lot to push the boundaries. If you think this is a lot, then you should maybe listen or don't listen to Salt Altman, because he like $7 trillion to completely reshuffle the AI industry and to make the biggest model and rule the world in a way. And this guy, it's running OpenAI, so it's not like a joke. He's really thinking about it. Of course, that will probably not happen, but nevertheless, these are the plans of the big companies pushing the boundaries. And as I will explain in the next slide, there are some scaling rules which are still valid. So the bigger the model, the bigger the data sets, the bigger the compute, you usually get better performance. And which leads us to foundational multimodal generative AI models. So let's now just for a moment skip the multimodal. Let's talk about foundational generative AI models. So what is a foundational model? Foundational model, in principle, it's a big neural network, usually very big, with, I think the biggest are trillion parameters, but they are all over 100 billion parameters mostly. And so it's a big neural network based on transformer architecture that you can see on the right hand. So this is the transformer architecture which is used across almost all foundational models. I'm not saying 90%, but not 100. So don't quote me that it's only architecture, but it's the most commonly used architecture. And the foundational model, it's a huge, giant neural network that you need to train. And usually until this year, let's say, or 2-3 years before, but really recently, these foundational models were trained on type of data. So if GPT-1 was trained only on text data, so you put text on the left, you put benchmarks of text on the output, and you benchmark how good it finds the pattern. And this was trained for text. This was trained for images. You put prompt in images. Does it replicate them well? Yes or no? So you train a neural network. But the latest neural networks are multimodal, and this started. Now it's difficult to say last year, because somebody will find a paper which was done 5 years ago, but it's not existing since 100 years ago. It's really something new in a way. So and the problem is computation. That's also the thing. But the latest models are multimodal, meaning that they are trained from multiple types of data. So they use text, they use images, they use speech, they use audio, they use everything inside. And these models are trained to perform tasks and benchmark on these tasks, like question answering, sentiment analysis, image captioning, object recognition, you name it. This is taken, I think, from Google Gemini, which is probably the first multimodal big trained network that was trained from scratch on multimodal data. And this happened, let's say, 3-4 months ago. So it's pretty or relatively new. As far as I know, GPT-4 is trained on text, but it's on par with DALL-E. And now I'm not sure of the exact how they function together. I would lie. But also OpenAI has also multimodal possibilities. So you can also put in GPT-4 images and get response from GPT-4, and understanding the images, it can also generate images. So it's also a multimodal model. But I'm not sure. I think it's not trained from scratch for multimodal. But this will happen. I mean, in the near future. So I think most model will be trained like this. Little bit scientifically, not to be like a presentation of companies and money. They're all built on transformer architecture. So transformer architecture was published in 2017. There will be now a very nice talk that I will listen to. It's hosted by NVIDIA. They will gather the original authors of the transformer architecture, which are 6 or 7 people, and all of them are CEO of very successful startups. Not startups, but very successful companies. That's also interesting. They were working for Google at the time in 2017, and when they published transformer, they were working only on text. So it was a language model, and of course, it was a good language model because they pushed the boundaries. But I don't think that no one of them was aware that they have found architecture that it's not only good for language, but it's good for everything else. So it works very well in images. It works very well in video. So this is definitely I think they didn't know at the time. And what is even more important is that this architecture can scale very easily. Now, I would not say train very easily, because this is like not a good, it's not probably true, or it's true. I cannot, or debate is too long, but definitely transformers can scale very good. So you can create very big transformer neural networks without too much problems. So they're really like packing and with a lot of heads and a lot of input. So you can build really complex, big neural networks based on transformer architecture, and of course, you can get a lot of inspiration from the open source possibilities right now. So this is how, at the moment, is to build a foundational model. You will use transformer architecture. Depending what you want to build, you can use one data, or you can use multiple data. Take into account more data or more complex data, more complex model, and more compute, etc. So it's all connected. Foundational model Llama 2, 70 billion. Usually the models at the end have like 70 billion, 7 billion, 2 billion, 50 billion. Now depends really. 130 billion. So these are the number of parameters. The number of parameters are how many are weights in the neural network, simplified. So how big is the neural network? And the bigger usually gives better results. So that's also a usual fact. You can use different types of optimization. So there is a distillation method. So you can take a big model, make it smaller. It will lose some of the capacities, but maybe it will perform with 90% of the bigger model, but you will have a lot of the smaller model will be faster. You will need less compute. You will need smaller computers, better interface time. So there are a lot of combinations, and you can also train a small model. So people are training 7 billion models, and they're pretty famous and popular, in fact, because 7 billion large language models can run on a normal computer. So you don't need a special hardware. They run on, for example, if you have a Mac with 16 gigabytes of RAM, you can run 7 billion models on your Mac. Not so fast, but they work. 2 billion is going to work even better. So the smaller models are useful because you can, get a sense how it works. If you need more smarter model, intelligent, then you need a bigger model. But in many domains and in many applications, I think even smaller models will work perfectly. So let's get back to the slide. To train a foundational model like this, like Llama, 70 billions, but I think there are 3 variants. If I'm not wrong, there is 7, one bigger, and 70. 70 is the biggest. So you take the huge chunk of the internet, like 10 terabytes of text. So it's a lot of text. You need like 6,000 GPUs for 12 days. I believe this number is for compute, only for money, for power. So you need 2 million only to train it on some cloud. And you will use this number of flops. So 24 zeros flops operations. And at the end, you will get 140 gigabytes of file. So this big file, you cannot run this file on your computer because it needs to be in RAM. So you need to run it on a couple of GPUs, which can be packed from NVIDIA and interface the Llama, for example, for your purposes. And these are the numbers for Llama. My point is that they use a lot of text. As you see, it's a lot. There is a lot of compute. And at the end, you get like a file. People sometimes say this is the compressed file of the knowledge of the internet or compressed file of the text. So it's really what this does. It's mapping input word with output word. So it's really like a compressed version of our internet. And I think it's even more visible when we talk about image generation, where you put a prompt and pops up an image. So I think this link, it's explaining in very simple terms foundation models. Maybe I didn't mention in the beginning. I will not go deep into some details because when we're talking with Maria about the presentation, it's going to be a big overview with some, let's say, important things for the geospatial community, but it will give you like a introduction to these things, not going deep into doing something code or something, because I think it's not so difficult, but this was the idea. These are very important things to remember. First is that scaling laws are still valid, and this is the holy grail. So there is a paper. There is the guy even printed a T-shirt with these 3 graphs, which really was amazing. I was thinking even to buy this T-shirt because it's really something. I will just explain the graphs in a simple terms. So in the simple terms, these graphs say this: if you have more compute, if you have more bigger data set, and if the model is bigger, you will get better results. So this was a comprehensive study. This is published in Archive that showed that bigger data sets, bigger model, more compute. Therefore, as I explained in the whole previous section, is a big rush to make it bigger, and Meta is buying a lot of GPUs. Amazon is not showing how many GPUs they are buying, but they are buying a lot. Everybody is buying. NVIDIA is making enormous amount of money because they really cannot handle the demand. They just sell, and of course they put bigger prices because everybody wants them. So this is the current moment, and this is because this is still valid, and this is why Sam Altman wants $7 trillion, because this is still valid. We don't have like how big and how deep is the rabbit hole. I don't know, and I think nobody knows, but everybody is rushing to build a better, more performant model based on this this knowledge. If you want to know a little bit more about foundation models, not a little bit, but I would say a lot, then definitely read this archive paper. It's a screenshot. It's not a paper, it's 200 pages. It's almost a book, but really captures everything from foundational models, who is building it, some societal problems, biases, risks, etc. So it's really long. So it's a nice read. Why everything works, or why everything is working, is because we are running on unsupervised learning, so we don't need supervised training data, which is usually difficult and expensive. So we can, we can just take the whole internet and train it on that. That's the power of the foundational models. And yeah, this is a graph showing how much compute you need. It's simple. The bigger the model, you need more compute, and in general, all the models are growing with compute demand. This is taken from NVIDIA. Now let's talk a little bit about open source, proprietary, language vision, and multimodal foundation models. So there are really a lot. This was it's impossible task to map them all. I will just focus on the most known one, the most visible one, but it's not. It's far from finished job, and it's a universe of itself. But definitely from language models, proprietary are GPT-4, BART, Cloud, and GPT 3.5. GPT-4, GPT 3.5 are OpenAI models. Cloud is an Anthropic model. So there are many companies which are building currently proprietary models in language, and they are really usually high performant, I must say. Better performant than open source. Open source is catching up, but still these are the prime leaders. From the open source, there is Llama, built from Facebook. There is Mistral, which is very, let's say, interesting company. This is a French company, which is building open source large language models and publishing them. They are really good. 7 billion is really, really great model. It's probably the best performing model. And there is Bloom and many others. For the vision, there is DALI. I think this is quite famous, and Midjourney are very famous, which are proprietary. In open source, you have Stable Diffusion, Segment Anything. It's amazing model from Meta. If you use segmentation in anything, I would definitely try out this model, because it's open source, it's free, it's available. You just download it, you can try it immediately. YOLO, you see only once. And for this audience, very important, NASA-IBM Geospatial model, which I will explain in a whole slide below, which I think is the first geospatial model, which is very great. And I think this community should definitely exploit this model and try to use it in their pipeline if they already have some kind of a data analysis and using artificial intelligence. For the multimodal, it's still early, let's say. I just put them because they are going to be the future. So it's Google Gemini and GPT-4 with DALI, and there are many, maybe others, but these are the ones that are more prominent. If you go on Hugging Face, as I said, it's a place. I think they have already 1 million models. So they have really a lot of models. People are publishing their models there, and they publish even how they built their system. So it's really a useful repository, first of all, for finding an appropriate model. But they also have a leaderboards for chatbots, for open source large language models. So it's really useful. So you can see how a model is performing, you can even choose sometimes, you need a more model that is more good for chatbots, but maybe it's not good for reasoning because your application is like that, or the vice versa. So you can choose a model. I took this leaderboard for chatbot arena, and yeah, still GPT-4 it is the leader. BART, it's Gemini, it's the third. You see the GPT, it's prevailing. Mistral, as I said, is really amazing model. Cloud from Anthropic. So these are the models. Again, at the moment, proprietary models are better. They are accessible through APIs, but for many applications, I can almost say with certain open source model will do the job. So you can use them from Hugging Face without licenses. For this, the audience, mostly this is probably the most important model that you should definitely check out. So it's NASA-IBM Foundation model. I must admit I didn't know it before. I was preparing the presentation. We had a talk 2 weeks ago, and I a little bit researched what is happening. And I found out this model. It's available on Hugging Face, so that's great. So you can download it for free. The weights you can plug and play in your application if you have already an application. And I think there are 3 models in a nutshell. So one is for burn scar segmentation, another one is for float mapping, and multi-temporal clock classification. So this is how these models were trained for, on this type of data, on satellite imagery data. They use VIT architecture and embeddings. So, but everything is open source. So if you Google it, you will find the model. I think you will find even the data it was trained on. So you have a lot of details. So you can see if this model it's working for you. If you're working in satellite image recognition, then definitely you should check it out and try to use it. Just to make it clear how foundational model works and why it is needed, and how what's the catch, let's say. The catch is that foundational model is usually a big neural network that it's already pre-trained on some task. So, for example, multi-temporal crop classification, I'm just guessing, but let's say for this model, they took a lot of satellite image data and then trained it to recognize this type of features. So now this model is pretty good in recognizing these features. They of course benchmark how good it is. You can take it and use it in your application. Now it's a big question. I don't know the details, so I'm a little bit guessing. But maybe your application is based in some area that is, let's say, Africa. So you have a lot of, let's say, desert, and this was trained on something else. So then it will not work very well. But if it's trained on the things that you work, it's going to work perfectly. But nevertheless, because it's probably trained on a lot of data, it has seen a lot of features. So you just need to fine tune it for your own purposes. So usually, very usually, foundation models are taken, but they are fine tuned for your purposes. So you fine tune it, but the fine tuning compute is very little compared to training a model from scratch. So when you take a foundational model, you in fact take I don't know how to make it in another, like a pre-cooked meal. So you take a pre-cooked meal. You maybe are not sure what is already inside, but you need to just put it in the microwave. It's already done. The heavy work, it's already done. This is how it works for large language models. This is how it works for vision. This is how it will work for vision for this model too. So this is very fundamental to know. Usually you take a foundational model, you have some supervised data, special use case that you know it well, you have the data in your computers, you just fine tune it on your data set, and you measure the performance, and usually always the performance is getting better. If it doesn't get better, you probably have some problem in your code or in your processes, but that's a different story. But usually it's always getting better. You cannot get it worse. How do I know this? Yes, this is the things that I have done previously. So, I don't want this presentation to be only for something else that somebody else did, but I want to show you that I have put my hands deep into these things. So I really was working hands-on with code, with models, with data. So I know all the details, mostly on models and code, to be honest. Data was usually prepared from other people, because I'm not a satellite image expert data. That's true. And what we did is 2019, when I joined the commission, we used convolutional neural networks for multi-class segmentation of Sentinel-2 imaginary or Sentinel-2 images. So we took Sentinel-2 images. At that point, we use UNet and SegNet. These are, in fact, convolutional neural networks, and train them to recognize features on the ground. So we had 7 classes. We had rivers, we had agriculture, we had forest, we had towns. So we had 7 classes that we took the cadastral data, and we trained a neural network to recognize this satellite imagery. The case study was in the Netherlands because they had a good cadastral data, and it was available online. And we got, I would say, pretty high results. We try out different types of block sizes. These are things that we try out. I don't want to go into details because it doesn't make sense, but we try out different types of neural networks to see how they perform. In a nutshell, this is 2019. In 2019, there were no foundation models, or I cannot say that they didn't exist, but definitely I would not, I didn't heard in 2019 foundation models. I think they're a relatively new thing in the last 2-3 years. And this is how things were done in a sense. So, but if I'm doing the same research right now, I would definitely use NASA model in my pipeline for start, just to see how it works out of the box. And after that, maybe use this model again and benchmark it with it. That's a different story. But definitely, I would start with a foundation model if there is available one. At that point, I would say it was a little bit more difficult than now to patch all the things together. You need to use Keras, Theano. I don't want to read all the things. Now I think it's a little bit more straightforward, because with every year, the tools are getting, I would not say simpler, but at least easier to use, because it's all Python, and the commands are getting packed into one command. This is the usual case. Another research that we did, which, let's say, it's very similar to foundation models, and again, this was not labeled at that point a foundation model, which is definitely a foundation model, is that we use eNaturalist 2017's computer vision model to recognize invasive alien species. So let's just first explain what is eNaturalist 2007 computer vision model. So each year, I don't know if the competition is still ongoing, but at that point, each year there was an ongoing competition who is going to build a better computer vision model to recognize species in the wild. So this was eNaturalist model, which was the competitors. In fact, the guys who were winning were always like Google, Microsoft, because you need enormous amount of compute, and they had it, and they use the data set, so they train it, and it's recognizing out of the box a lot of species. Of course, the percentage of recognition is not that high for all the species. Whoever have trained a network knows, so there is usually a long tail distribution. Long story short, we took this natural computer vision model and we tried to see how it works out of the box to recognize invasive species that we had in our database in my unit in the GRC. Invasive species are really some species which are, these were, I think, happening in Europe, so we have the data set. And what we found out that we had one hit, that means correct recognition of the invasive species with 35%, which is extremely high. Out of the box, just put the model, sending him a picture, and it's getting this kind of percentage. In the 5 hit, we had 12, and no hits less. The follow-up research, which I was not involved, but of course I was a little bit advising, was to fine-tune this naturalist model on our data sets, and of course these numbers got higher, because when you fine-tune it, then it's recognizing much better your features or your images that you're giving it. As I said, since ChatGPT, I'm very much into large language models, and I built some project together with friends, together with colleagues, and try to find a market for them. The first one would be large language models with retrieval augmented generation, which on documents, which I think it's really amazing feature. In a nutshell, you can build a system that is ChatGPT, but on your data. And when you ask a question, it's going to give answer based on your data with citation. When I saw this possibility, I immediately built the prototype on my research, on my publications in the GRC, and it really worked very well. So you can ask a question, and it's going to find the corresponding parts of the text that you answer this question. Using OpenAI API, it's going to generate you a coherent answer with citation. And very important, is not going to hallucinate, because hallucinations are still a problem in large language models and everywhere, in fact, in deep learning, meaning that it can invent things. In this case, no invention. It uses the source data that you're giving it, and it's very practical for many applications. I mean, the possibilities are endless. You could put it in your company, all your data, and you can ask a question, and it's going to give you like a GPT-4 response, like a human response. You can read, I don't know, how much we sold last year from this point to this point, and who sent this email to that one, and what was the response. It's going to give you back and it's going to give you a citation, so you can click and follow up on the document that you have provided for. And another idea that we are working on, it's interview bot. It's really nice because you can really build high quality a bot that can help you prepare for an interview using large language model technologies and others. So it's really something amazing. I finished, let's say, with the part of large language models and capabilities and who is doing what. Now I will talk a little bit about some challenges that are obvious because it's not only rows, so there are also, it's not only rosy pictures, so we have to be aware that there are all colors. So first is, with great powers comes great responsibility. As we use AI, the more we give it, the more responsible it is, because it's, it will interfere human life. So definitely. And nothing vast enters the life of mortals without a curse. That's also a very good statement. And it was at the beginning of a very good documentary that I read this statement about social networks. So it's really like that. So whatever technology, whatever invention, there is always a good and a bad side. So there is always a balance. So no, not only good. There are a lot of AI risks. In fact, many of my colleagues were working on this. So if I start talking, I can talk for very long, but I won't. I will just highlight some of them. For example, privacy. These models are trained on everything on the internet. So 40 terabytes of data contains everything, contains names, surnames, email address, telephone numbers, social security numbers, you name it. So they're all trained on everything. They can really, they know everything in a sense. Now, can they generate everything by word? That's a different story, but I won't go there. There is a privacy concern. If it is for the geospatial data, could be location data. So there is a lot of location data already there that these models have seen and been trained on. So they will probably generate it in this way or another. Content authenticity or deepfakes. I think the picture is the right example. These are becoming completely very difficult to know what is true and what is wrong on the internet. And this is a problem, I would say a big problem. And there will be a lot of content moderation. And believe it or not, the poison is the how it's called the AI, and the remedy it's again AI, because you need better AI tools to detect these things. So, and this is how it works, and it's true. So big companies are building AI tools to detect deep fakes and take them out of the networks. For AI, geospatial AI can be trained on one urban areas and represent something else. So this is maybe also, this is for biases, in fact. So, but for content, you can generate landscapes with deepfake satellite imagery, which probably are also going to be undistinguishable from the reality. Bias and fairnesses, we usually, if the data is biased, then definitely we will have a bias system. There is a lot of debate. We need to figure out how to improve our systems. I would not go deep. Fairnesses, it's a very word which is used a lot, but it's really depending on the objective function and who is building it and how is building it. I would just say that it's difficult to build these models, like an image on, we all want to be perfect, but the last model that Google has published has got very big large language models. They got very big response from the whole community, because the model was designed to give answers which are not right, I would say, or not true, even on historical facts. So I think that training these models, it's a difficult job, definitely, but we should try to give them the most trustworthiness that we have in our society. But also have in mind that models that work well in our society, let's say Western society, are definitely not going to be in a way compatible with other societies, because other societies have different values even from start. So it's super difficult, but I'm not into putting into models some facts which are currently on the famous or something, which are not true. So this is very important. For the images, maybe it's different, but I was talking mostly about large language models and the current debate in Google, but we will see. Transparency was always the problem in neural networks, because these are generally black boxes, and it's very difficult to say how the decision or how the prediction was made. In fact, it's impossible. But yeah, these are also moving targets, so things are evolving. Definitely, open sourcing makes a big difference, because in that case, really, the community will know how the model is working, at least input output, and can have more quality assurance in a way. Because in the companies, you will have always limited resources to let's say test the model. Open source, it's I think the resources are more big, because everybody can test it. The AI Act, if you're working in AI, definitely check it out. I think it's published. I was also contributing to part of it on the technical side. Good part is that, which I think was good, so definitely that many of the applications will fall after minimal risk or limited risk, so there will be no need for let's say complementary for regulatory filing up forms and justifying and all the regulatory burden. But of course, there are some unacceptable and high risk systems which will need to be investigated more deeply. If you're working in this domain, definitely you should check out the latest version of the AI Act and see how this will influence your business. I would not go deep into this. This was one of the first regulations in the world, as far as I know. On AI, there is very little regulation in the US and China. There's definitely room for regulation. I'm for, but we also need to think about not putting burden on startups especially, and think about how to, in Europe at least, how to promote more AI, not less AI. So I think we need to also have regulatory that will support and push towards some of the developments and catch up, let's say, the big tech in the US, at least on some level. So this also should be part of the regulatory machine, not only regulations. Of course, some are really needed. So it's not that I'm against regulation, I'm definitely for, but also think about support of companies, especially startups. This is I don't know how much time I have more. If somebody can tell me, it would be good, because I can talk.
Yes,
good?
Blagoy,
5
we
minutes?
have still totally half an hour, but then we want to have 15 minutes at least for questions. So
perfect,
you can
perfect.
speak for more 15 minutes. So go ahead. Yeah.
15 minutes is probably a lot.
Yeah, that
because,
is super
this is
interesting. I'm so happy about that. It's much more than what we discussed about it. So thank you so much. So please go ahead. Go ahead.
This was the slide to ask how much time I have, because this slide can take 5 minutes, half an hour, really. I can talk on this slide how much I want, but let me give you my recommendations for time being and for near future. And this slide is what works and what won't happen. And first, this is not a debate, because there was a lot of debate of this and that, but I will tell you, GPT-4 works, so it's not a debate at all. GPT-4, the latest model of OpenAI, works amazingly. It's something that I use it daily. It's so good. It still blows my mind how good it is. So I'm on forefront and still impressed by this technology. So language is, in a way, I would not say solved, but really solved. The famous Turing test, nobody talks about it anymore. And this was the test for real intelligence. And GPT-4 broke it. So it's not already test for intelligence. So, and this was the holy grail for test for intelligence. It was test for intelligence 3 years ago. So, but nobody now talks about Turing test, because GPT-4 will pass it like this, no problem. So language is really already solved. All new versions are going to get just better than the current state of the art, which is already extremely, extremely good. So my recommendation to everybody is to start using ChatGPT for sure. And I think $20 are really well spent for GPT-4. I immediately bought it, and I don't regret any penny that I'm giving. So it's really, really good. And it helps me a lot in everything. First, I'm still coding, so I produce Python code, and really makes very, very easy to build Python applications using GPT. So it's almost like generating an image. You ask it to do it for you, and it's giving you a code. If there is an error, you can say, okay, I got this error on this code. Can you please help me? And it's helping you, and it's improving the code. It's almost unbelievable. If you think that's unbelievable, I was always like a coder, so backend. I never did graphics. You need graphics, is giving you graphics. So it's really helping, at least in the programming part. It's really amazing copilot, amazing. And I use it daily. I even published a blog. I was going to, make a new personal website, because I finished the commission. So, to find another job and maybe clients, I made a new website. I used GPT. I did it in a day. So I did it in 8 hours from scratch, built in Django and Bootstrap. Otherwise, it would take me at least 2-3 days. So it's not possible to do it in one day. I did it in less than because I used extensively GPT-4. After that, I built another application also using GPT-4. Works amazingly. So really, this is AI will replace programmers. No, But programmers who use AI will replace programmers who don't. Yes, and this is a fact. So if you're a programmer, use GPT. If you do something, use GPT. Again, this is maybe becomes an open AI commercial, which completely is not the point. The point is, if you don't use ChatGPT, use BART. If you don't use BART, there are many other versions which I previously said. I didn't have time to test them all. It's almost impossible, just to let you know. But again, on par, you have a lot of different options to try out and to use. So I strongly suggest, if you do something, try to see how personally GPT-4 can help you. And I use it even for medical advices and for everything. In fact, if I'm traveling somewhere, I ask it for travel advice. I'm going there on holiday. What do you recommend me to do in these 3 days? I have this time. What is the best place to go? Where are the parties? Or I don't know, I want to see monuments. Where are the monuments? It's really great. So I stopped with GPT-4 commercial, move to other. Image video. You cannot read this, but Jan LeCun, which is a great guy, he is leading Meta AI division, chief scientist and everything. He's really good. He made this was a Twitter post, and I was thinking the same, but he made it better, and I must say with better words than me. That I will write it. So he wrote it, but it was really in my mind. I had the same point. The point is this: language is solved because in language we have like 10,000 tokens or 15,000 tokens. So language is tokens. Let's translate them to words. It's not words; it's part of words, but you can see them as words. So we have like 10,000 words. It's a long tail distribution, so we use some words more, we use some words less, but it's still like a fixed domain. So when you map 10,000 to 10,000, you map 10,000 words to 10,000 words. So you don't map. And now let's go to image. Image, just by definition, you take a pixel, it has 3 numbers or 5. You have red, green, blue. And these are from 0 to 255, or I don't know, if it's high resolution, it's even more. So you have a pixel, you have a number. You need to map pixel to pixel. I mean, it's enormous. The scale is completely different, however you put it, but it's still a number. There are ways to group them. We use this tool, so it's not that really every pixel it's mapped to a pixel, but still convolution, it's compressing them. But nevertheless, we are talking about pixels, so it's a completely different ball game. It's super more complicated, computationally more expensive, more difficult, and if you think about it, it's super difficult to build these systems, to map pixel to pixel on an image. So therefore, the tools that are built don't have the GPT-4 language solutions. So this will take a little bit more. Therefore, we don't have autonomous driving. It's going to happen tomorrow. It's going to happen. It's still not there. So this is still thing to do. But researchers are doing it. So, and the high performing models are really high performing models. So if you take foundation model which is high performing, is going to definitely be better than anything else before. So it's not a question about that. So you will definitely have like a better performance than anything else before. But this will take time. It's not tomorrow. I don't know. Now to put a number or date, it's really I don't think it's fair. But this will go. For video, it's a completely different ballgame. Video, it's a 30 frame per second images. So it's super difficult. Therefore, the latest model of OpenAI was really like, people said, wow. But this is also going, the computation is going and everything is slowly improving, as I showed on the slides. Now, Doomsday AI. This will not happen. However, it looks like, I think the discussion should not be about Doomsday AI. There are very lot of applications or problems in AI, issues and risks that we should be aware of, like deep fakes, like bots all around us. Social networks are full with bots. I'm afraid to comment anything because I had like 20 comments which are bots. You see that they're bots. So And these are usually now with open, they're all filled with AI because it's very easy to build them, and they will become even more intelligent. That's also a big problem. So these are the, let's say, the problems that are right now, and focusing on something that maybe it will happen. There is no, it's not a zero chance percentage that we will have more intelligent agent from us, but it's not the thing that we should be worried about at this moment. So we have really a lot of things to worry and risks. There should be definitely a debate about doomsday AI, but not like the main debate, and this is the biggest problem to solve. No, that's not the way. I mean, I sincerely think that we are coming to some intelligence which is really higher on some levels than the human, but it's not going to happen tomorrow, maybe not after 10 years, maybe not even after 100 years. So, but still, it should be debated, but not not as like the biggest problem. And unfortunately, in the media, it's getting this kind of attention. And yeah, this is the meme. I mean, this is the usual case. So that's true. My observation: people don't use it enough. I think again, this is from people that I talk with. I always am surprised, especially with colleagues that I work with. I always say use GPT-4 to help your problems. They don't. After 3 months, they still don't. But I cannot force them. And yeah, maybe everybody should use at least these tools because first, it's going to improve your personal productivity, and recommendation for the companies is to start employing them into the systems because this is already established, or let's say good, strong application. So it's going to give good results. It's not that it's going to and plus you're building infrastructure for your next future. So these are just going to improve. And yeah, 1 year, 7 regular year, 1 AI year, 7 internet years. Even for me, I must admit, sometimes if you don't, the pace of development is really, really high. The things are changing very fast, and it's also difficult to keep up. So invest in human capital, invest in retraining your workforce, your colleagues to use these tools, invest in building up solutions. It's not so difficult. They're open AI, but there are a lot of APIs, so you can access these models with API. So you don't need it in-house. You just put an API and communicate with it. You pay for it, but you can build prototypes. You can see how it works. You can feel if it's solving your problem or not. So I think this is very, very good. For open source models, they are all available on Hugging Face. If you have need, definitely use them. I would not bother too much about the infrastructure. It's here just to say it, but yeah, no, use rented infrastructure. If you really need, then you buy GPUs, but having to mind this, it's still more low on steroids. So every new generation, it's 2 or 3 times faster than the previous one. So if you buy a GPU in 3 years, you need to buy another one. And if you have a wife like mine, she will say there is no way you're going to buy 5,000 euro PC again. So yeah, this is life. You cannot do it. Yeah, depends. I mean, but definitely use cloud as much as possible. It's some resources are even free. Kaggle is free. Google still gives you like to run some optimization on their services. For this audience, definitely check out NASA-IBM. I think it's the first geospatial foundation model. Yesterday, I attended a workshop. They had talked about a large language model which was trained on geospatial knowledge to work with geospatial vocabulary, let's say. And it was trained on Llama 7 billions. It was done by Chinese researchers, Chinese Academy of Science. I didn't put it in the presentation because I see it yesterday and I was too lazy to put it today. But I'm telling you now at the end. So I think it's not a, let's say, difficult project or things to do, because if you have the data sets, which they were generous enough to put them all online. So if you find this model and you can build maybe, for example, a bigger model and see if it's performing better on geospatial texts. I'm talking about text, not maps. And there will be special domain large language models. They're popping up in every domain, medical, financial. So, but also have in mind that GPT-4 it's quite powerful and it's covering really almost all domains. So now, should you build or open source? It really depends on the problem that you're trying to solve. Last but not least, large language models on your data. I think this will be the future. Everybody is doing it, and this will become some kind of a default very soon that we will have. If you follow, Microsoft is putting AI in many of its products. I think the last version of PowerPoint was asking me, do I like to do the presentation with a talk, and AI should improve my talk, tell me if I'm missing something. All these things are happening. There are a lot of opportunities, I think. So yeah, focus on the opportunities. I will keep this short. AI is the new electricity. It's a fact, not an opinion. It's going to be everywhere because it's everywhere. If you don't trust me, see how many chips NVIDIA have sold last quarter, and all these chips are for building AI, and they're going to solve even more chips in the next quarter. They're going to be again for building AI. So AI is going to be everywhere, from our phones up to the cloud, everywhere. We're going to use it. Everybody's going to use it. The big companies are building it. Small companies are building it. Everybody is rebuilding their software to be more user-friendly and be easier to use, because it doesn't make sense to click 100 times manual work and do the same routine 100 times, which I was optimizing since a long time ago. So this will happen. There will be a new interface, voice, text, images, video. If you are a paid user of GPT-4, you can talk to GPT-4, which is this picture. It's really amazing, works very well. So you talk like with a person, he's giving you advice, you ask him a follow-up, he's giving you again advice. It's almost beautiful, it's very, very nice. So in the future, we will have less keyboards and mouse. We will be having more voice and talk, and the computer will understand and do what we ask it to do. The iPhone moment was last year. It's not anymore. Everybody was doing it, and now everybody is doing it. So iPhone moment for generative AI. As I said, Apple is stopping production for cars, going to AI. Multimodal is the future, definitely. Google started it. Everybody will follow. You need a lot of compute. Internet companies made trillions value. AI companies are next. That's also true. Therefore, the big trillion companies are investing a lot, because there is always a chance that there will be a company that will change the world forever using AI. The closest thing that I can think of is search, which I think Google search is very much, I would say, not destroyed, but hit by ChatGPT, because many people are now asking ChatGPT without going into search. And this will even improve. So the search will become not maybe obsolete, but not used that much. And, this is the prime Google tool across many. I mean, Google is big, so they use mail, they have everything. So I'm not saying that they will go bankrupt from that, but they will use probably their biggest weapon on their biggest product. And last but not least, several geospatial foundations will be made this year and next year. Why I say this? Because the entry level for building a foundation model is getting easier. The codes are usually shared online for free. Compute is getting cheaper. Data sets are also getting bigger and more available. This is like a trend which will not stop. So the next year we will have more foundation models, geospatial, that I think whole community can use. This is the last. I hope I'm not so boring. So David Chalmers says one critic of large language models, blah, blah, blah. And Jan LeCun in September 2020 says, can large language model figure out this? And he's making a problem that is probably difficult for a human it's easy, but for a large language model it's usually difficult to figure it out. And after 1 year, GPT-4 can do it. So what's the the hidden story behind this? The hidden story is behind this that even Jan LeCun, who is really on the top of the notch of the science in AI, was surprised by the GPT-4 revolutionary algorithm. They used reinforcement learning with human feedback, I think was the missing point that previously large language models didn't use. But nevertheless, it really pushed the boundaries very high. Nobody expected it. If Jan didn't expect it, I think nobody expected it. So sometimes there is a breakthrough which changed the industry completely. GPT-4 or ChatGPT was this kind of breakthrough. And whoever says that they knew that this will happen, I think they're usually lying. But again, we can also have like breakthroughs in future, in vision, I hope, and maybe even in video, although the debate is that they won't happen that fast, which I a little bit agree on this, because really computation is huge. But there could be also a breakthrough that will change the vision completely as we know it, and it will have like a GPT moment for its own. But even at this point, they are still performing much better than anything else we had before. So I will finish here. Thank you for your attention. I hope I was presenting you something that you didn't know. I hope I presented something that you know. Now you have, let's say, more time to digest and to maybe ask some questions, which I think Maria will take over. I should stop sharing, I think, now.
Yes, thank you, Blagoy. I will call also Rohini with us. So amazing. Thank you. It's one of the best presentations that I have seen, I have to say. Yeah, I'm very happy. I want only to add something for the floor. You mentioned some papers in archive and the book specifically in archive. I want to tell everyone that if they are interested in this book, for instance, on the opportunities and risks of foundation models, this is open, so they can find it openly. So you can download it. You can download all the papers in archive, and there are very nice papers about this topic. And so specifically, if there are young people who are very curious and angry about that, please check and download and read. And so thank you, Blagoy. We have one question from the floor. I have a lot of questions but and curiosities, but we have a question from the floor, which is by Michael Spicer. And he says, thank you for your great talk. And then he asks, if you are familiar with it, could you comment on the Swiss AI initiative by ATH, Zurich, and EPFL to train foundation model in an open and transparent process? I don't know if you are familiar with that and you want to answer. Okay.
I don't know the exact initiatives. I must say, I will Google it after the talk. I think it's good. Training a foundation model in an open and transparent process, it's in fact excellent. Why? Because first, I think it's very good for the whole community, because you have a lot of scientists that don't have this compute infrastructure. They cannot do it even if they want. Now, if somebody is doing it in an open and transparent process, they can see, they can see the data sets, they can see the processes, they can see how the training is going, the optimization algorithm is getting better, so the error is decreasing. They can maybe even see some flaws during trainings because they happen. Sometimes there is a problem, it's solved, so everybody in the community knows that there was a problem, which we don't usually publish in papers, unfortunately. We only publish the good things, but we also should publish, the pitfalls, so people don't do them. But if it's an open and transparent process, I think it's really amazing. at the end you will get a large language model. Now I don't know about this specific, but I think Bloom was trained in the same manner. It was done by Hugging Face and many other stakeholders. I think if you Google it, Bloom was in a sense also in the same manner. So it was open and transparent. I really like this approach. There are a lot of advantages, especially for engaging more people and sharing the knowledge. I think this is really crucial. At the end, this is the whole community gets a huge benefit out of the process.
Okay, thank you. Thank you. Then I see that there are other questions. So I don't know if Farini, you want to help with other questions from the floor?
No, absolutely. Thank you so much. I completely agree with you, Maria. It's one of the best presentations. I'm so excited to be listening in. So we have this great question from Jay. Jay says, oh, wonderful talk. He's thanking you to begin with. For those of us starting their journey into ML modeling or research, what is the best way to do so? For example, he seems to have a background in cloud engineering, but would like to move more towards ML engineering. What your advice would be?
Oof.
To study more the geospatial field.
That's also true. I must say one thing which is great. I will be short because this is a huge question. I will be short. The good thing is you have a lot of open source resources. That is very good. So really to find books, courses which are free. I would definitely check Andrew NG courses, which are really good, and all of them, in fact. Now, top was on my mind. I think also Google offers open courses. Coursera has a lot of open courses, so I will start here. Definitely take some books. Now books they change so fast that it's almost crazy. But I would definitely take a Python book for machine learning. I think Colette, it was the name of the founder of Keras, has a good book. So there are resources. That's good. And last but not least, for me, an eye-opening was Kaggle. Because in Kaggle, you will really learn a lot. The code is open, the discussion is there. If you find a problem, and if you're having time even to participate in Kaggle, I think it's really going to change a lot in your ML knowledge and experience. So this is the path that I will go to: courses, books, and less Kaggle, or not go to Kaggle before, because you have to know a little bit before you go there.
If I could follow with just one more question, which Michael Spicer has here, which is also something that I wanted to ask as well. In geospatial generative models, what, in your view, are the most promising approaches to obtain models that are compatible with physical constraints? And to add to the second part, in a more generic term, what do you think we need? How do we start in building these geospatial generative models?
This is a question: how to build geospatial generative models. Okay. First, again, you need to find, I would say, place where is your application. So you're not going to build a model, you're going to build a model, but you're going to build a model for your problem or the domain problem. That's one thing. Second thing, I'm always going towards satellite imagery, because at least this is a little bit more than the other things. So in satellite imagery, you have a lot of data, which is Sentinel data, freely available. I think I'm not the right expert now in detail, so give my grain of salt. Especially there is NASA, a lot of big database for images. So there is also, you can use probably some other types of images from other satellite. Planet, I think it's some big constellation of satellites. So you have this data. Now you need to find your domain problem. And to be truth, first, what I will do will definitely investigate very well what NASA and IBM do, because it's already there. And after that, try to replicate what they did. First, starting with the smaller model, of course. Don't make a big model at the beginning, because the money is big. So try with the small model. If it's getting you like a good result of the problem domain that you want to solve, then just scale it and don't worry. And of course, go 7, 15, 70. So you don't start with 70 if you are not Facebook or these guys who has a lot of money, and it's a different story. But yeah, this is how I would approach building a geospatial model.
Okay, so yes, clear. I have, because I see that there are no other questions from the floor, but I have a curiosity, Blagoj. I hope that this is not taking too much time, because I believe that beside what you said, that referring to images, and then there are multispectral, but also hyperspectral images, video. This is making more complex everything, and so on and so on. But what we can say, considering this foundation model, generative AI, and the metaverse, because this is another big challenge that is strictly related to this concept of foundation models. So even speaking about the metaverse, we are going from the concept of digital twin Earth to the metaverse. Also, probably thanks to this generative AI that will be really the basis. And with respect to that, obviously, there are some other points that you didn't have time to mention, like, for instance, standardization, open standard, the importance of open standard in this process. And you didn't have time to deepen into this. But I want to understand if you share with me the same impression that all these things are strictly connected, and specifically speaking about the metaverse, in my opinion, this is giving even more importance to this geospatial domain we are considering. Because really the metaverse can't exist without having the spatial and temporal contextualization of everything around us. And so starting from this big concept, I want then to ask you to go to the what we need, which are the elements we need, and specifically focusing on what you think that are the most important with respect to creating standards for these applications.
First, I completely agree with you. This is all interconnected, and breakthrough in one field implicates breakthrough in the other. So, for example, this, 3-4 months ago, Apple, it's pretty expensive, like 3,400 euro, I think, and it's only available in the US. So you have the glasses and the spatial. They call it spatial vision or something. What Apple has built, and they have the avatars there. So people were complaining about the avatars. So avatars will become, now it's probably version 1, but in the next version the avatars will become much better. Because even in the introduction of this speech we had a great avatar. So this will come out of generative AI, and they're going to immediately pop up in the metaverse with very good characteristics. In fact, I was thinking now as we speak, if you build a great avatar, then to build let's say this kind of talk, you can use very low bandwidth because you already have the face as information. You can build very nice virtual environment. So again, this is all interconnected, and people are working hard to push the boundaries, make better products. As I said, language is pretty established, I must admit. So if I would bet, again, I would bet on language at the moment, because really this will, the application will still explode, and it's already a very good product. About the images, it's a work in progress. Definitely is going to get improved. And on the standardization, You know, we were talking about this in the commission for a while. There will be standards. There's no doubt about it, but I think it's still a relatively exploratory phase. And I expect to have more standards for language for the beginning, because really this is like a place where, let's say, the processes are not well known, but okay, we have something solid, we can standardize it. But for the vision and for video, they are still really like super exploratory, and I don't think makes sense too much to make standard. But for the language, yes, and also standards, I think some open standards would be very valued even by the companies, because in that case they can benchmark their products. Because if you give me a standard, you know, if it's a well described and I don't know, have as a data set that I can fulfill, it's perfect, because I will always try to avoid some let's say bad intentions, which companies in principle want to avoid it because they will lose clients. So it's not that in their interest to do it. But yeah, I think it's a hand to hand. This also has to come from the government, but it's definitely needs to be supported by the big tech, because governments don't have the capacities to, or have limited capacities to do a lot in this field. I know, let's say even from the insider information, it's difficult. And plus, changes are rapid. So it's also a big challenge for the regulation, because if you know, we started, let's say, AI Act before ChatGPT, and you know, ChatGPT happens now. You need to regulate different things. So regulation also should be faster, bigger, but it needs to be hand with the companies.
Yeah, thank you. And I have a very last comment, Blagoy. I'm very happy about how we met each other. And I want to tell to everyone, because we were involved in some projects related to citizen science.
Yeah, sure.
And this means a lot to me, because as I'm interested in involving more all the people in science, and you share the same interest, the same willingly. So all these things that we are discussing now, generative AI and foundation models, they have to be for the people and with the people. This is the point. This is the point. This is the very important point, and this is the reason why I'm so happy that you gave us a so beautiful presentation. So I thank you again, and I call here now Rohini to see if she has something to add. Rohini is representing also UN, in some way the Geospatial Agency of UN. And so also from your point of view, Rohini, do you want to add something?
Thanks, Maria. No, I must say the potential for these foundation models are exceptional. I think we are in such an exciting times to be in the geospatial field. And this presentation opened my eyes to so many more ideas that I'm looking forward to try to work. And it's going to take time to operationalize, but thank you so much for planting those seeds in our minds. I think that's the first step that we needed, and I'm really looking forward to where this goes from now on. Thank you so much, and over to you, Maria, and then to Andrea.
Yeah, over to Andrea, I believe, because we are late, but was really worth going ahead with this seminar. Thank you, Blagoy, again. Over to you, Andrea, now for the closing.
Thank you very much. And first of all, I want to thank Blagoy for this great webinar. Really, I also found it very, very informative, very clear, and excellent. I want also to remind the audience that the presentation is available in the neural network so that you can download it. And of course, you can also watch the recording on YouTube and in the neural network where you are connected right now. I also, of course, want to thank Maria and Rohini for having moderated this event, and thanks also to the audience for a very active participation. I also want to remind the next planned events for the GI discovery. On March 12th, we will hold a seminar about the new climate change initiative, high-resolution land cover map from the European Space Agency. And of course, I want also to remind the audience about the GI workshop at the AI for Good Summit on May 30th. A workshop on navigating GI, plotting the course for future education. This GI workshop organized under Maria leadership with participation of all stakeholders from academia, private sectors, United Nations, will showcase the deliverables of the 4 international working groups which were set up following the GI workshop at the previous AI for Good Summit, which really highlighted the need for educational frameworks in GOI. So with this, I like to thank all again. I would like to invite you to follow these exciting developments in GOI. And with this, let me give back the floor to Anna. Thank you.
Hello, ciao.
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 Thank you.
Thank you.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.